Okay, so we're going to talk a little bit about rounding off. So everybody's rounded before. I know you've all heard the rules. If the number next to it is five or more, then you round up. If it's less than five, you keep the number. So we're going to talk about rounding, but I want you to think about why we round off, and hopefully, if you keep that in mind, it'll make some of the rules a little bit easier, and the whole process of rounding off maybe a little bit less confusing to some degree. So, first question you might have in your mind is, why the heck are these nuts and bolts? So this is a bolt, and these are nuts. So there's a nut and two bolts. Why is that there? Okay, well, the reason is because I want to emphasize why we round off. Well, when we round off, what we're really doing is we're finding the number that is good enough, that's close enough, and so when in real life situations, that's really what we're looking for. Is we're looking for something that's real life. I mean, that's close enough or good enough. The reality is, especially when you're measuring, you can never get something that is exact. I mean, we can measure something with a measuring tape or something else, and we can do a better job or a worse job, but we're not going to get something exact. It's more difficult to do something that is more precise, so we can get more precise or less precise, but we never get exact. So if you're manufacturing something or other things, we need good enough. So this is what I mean by good enough. So there's the nut that fits on top of this bolt. Both of these bolts are the same. They're the same size. The head of the bolt is 19 millimeters for both of them. And you can see they're the same length, or pretty close. And they're the same thickness or diameter. Okay, one of them I just threaded on. Second one starts off and starts to turn also, but then what happens? It sticks, and you know it really does. It makes it's hard to come on to turn right here, and the reason is because the thickness or the diameter of these threads is slightly thicker, a little wider. So this one's a little bit bigger than that. This just enough so that it's a little bit loose. See, it's a little bit loose, but it's just loose enough so it'll go on, and not too loose that it'll fall off. This one is not so loose, and then in here it gets to the point where it's not loose at all. It won't tighten at all. There's too much friction. It won't go on. The real reason is because it's a little dirty, and that has made the threads a little bit thicker here, and so it won't turn. Not by much, but a little bit. So that's not good enough. So that's all we're doing when we're rounding off. We're finding what's good enough. Now, good enough might be to the 10th place, 100th place. It might even be something much bigger, like the tens place. Like, let's say this was miles, and we were wondering how far we traveled on a trip in a car. Okay, well, we don't necessarily care about a tenth of a mile or a hundredth of a mile. All we care about is, we went about 700 miles. Okay, so that's rounding off. And so anyway, let's take a look at how we might do this. Let's say we're rounding this one off to this place, which is the ones place. So rounding to the nearest whole number. And what we're going to do is we're going to look at not just this number, but this number and this number together. So what we have, if you look at those two digits, is we have 21, and we're going to treat that like 21. Now the question is, does it stay or does it get bigger? So that puts it between, if we count by tens, it puts between 20 and 30. So all we're doing when we round off is we're asking ourselves, which one is it closer to? And it's much closer to 20. So this one right here, we would round off to about, keep it the same here, 682. And then we don't need 0, so it's just 682. On this one, if we're rounding off to this place, that's the nearest 10th place, right? 1 decimal point. Okay. Then we're looking at these two numbers. So we have 746.389. We want to know, is 39 closer to 40 or closer to 30? So you look at this as a 2-digit number, and you look at the next 10 and the 10 below it, and which one is it closer to? Well, that's the one it's closer to, 40. So we'd say 746.40, but we don't need that 0 because 0.40 and 0.4 are the same. So we're going to say that's about 746.4. Okay. Now, the only one that doesn't make perfect sense, if we're looking at it this way, is with the 5. Now, if we're going to round this off to the nearest 100, so that would be ones, tens, hundreds, that's where we're going to round it off to. So we have this as 85, and we want to know, is it closer to 90 or closer to 80? Okay, now the reason I say it doesn't make perfect sense is because, well, it's not closer to either one. It's halfway in the middle. So all we do here is we want to have a standard way of doing it so that everybody does it the same way. And when it's exactly in the middle, we're just going to move it up 1. So it goes from 85 to 90. So our answer would be, can you change that to a 9? And then we need the 0 here because it's a placeholder. So we need 900. So 852.38, well, that's pretty close to 900. That would be good enough, depending on how we're rounding. Now, in real life, most of the time, this is the process that you would use. There are times where you might round down, or do things slightly differently for various reasons. Sometimes for safety, for instance, you need to round up. Actually, not necessarily round up, but you have to build in a safety factor for certain things, and so that would change how you round off. But for our purposes, that's how we're going to do it.